Hello and welcome back to the Lathe restoration series. Today we will be looking at the headstock, so the part that is missing here. If you're new to the series, I am currently restoring my 1930s, 1938, 1939 Weisser Model EE lathe, and I'm making a little bit of a video log about it. And the first video in the series now will be about this, the missing headstock. So to start with, we are going to paint it. We're going to have to remove the old paint, probably sandblast it because it is likely a bit rusty on the edges, apply new paint, and so on. Now, you might notice that there's a little bit of a continuity error in this video because movie magic, the part I'm recording right now, I'm recording after I already sandblasted and cleaned and painted some parts because I completely forgot that I actually need an intro to the video. So, excuse the lack of continuity, I'm gonna have to see how I can edit this together. But again, we will be working on the headstock now, so let's go to the painting part. Yeah, paint is flaking off, it's rusty. It's surprisingly not as rusty as I would have expected it for, having all the paint flake off of it, but it is definitely rusty, so. Alright, I was just about to start painting when I realized that I should probably make a bit of a video clip about this. I just came back from the place where I sandblasted this. You might have seen a little clip of me actually taking it out of the chamber. To be quite honest, I'm really happy with how it turned out. Yes, I'm wearing gloves so it doesn't get oily. I sandblasted it with glass shot, so the surfaces shouldn't have been too damaged, hopefully. Especially like the bearing journal down there. Journal? Is it? I don't know. But yeah, I'm very happy with how it turned out. The inside of this thing I'm going to paint back red, just as it is in the lathe. If we just look back over here. The red I chose is apparently quite a bit more red than this. But since I plan to hopefully repaint this at some point in the future, I suppose it doesn't really make that much of a difference. Oh, also I thought I should probably mention what sort of paint I'm using, because people might ask. It's this sort of special two-component sort of epoxy type paint. It's supposedly super resistant against oil and stuff, and I was thinking, if there's one place in the world that should be oil resistant, then it's the inside of the actual headstock. And there we go. That's the coat of paint applied. I must say that the red especially looks extremely nice. I also like the contrast in this. You can see that I did mess up the corner a little bit, but that's not too bad. Yeah. That part is up next. We'll be painting this next week, whenever I get to actually sandblasting that. I'll also be sandblasting this thing here. The little high-low select. Yeah. Overall, I would say a massive improvement from this. Alright, that's the parts back from sandblasting. Let's unpack them. I did actually sandblast them myself, I just don't have a sandblasting chamber here in the basement, obviously. So there we go. They did unfortunately rust a little bit in some places. I tried to actually clean them off as fast as I could, like I literally just did this a few hours ago. Yeah, you can't see in there properly, sorry. There's a little bit of rust down in those holes, so we'll have to go through those with some Scotch-Brite or something similar to that. But those surfaces aren't going to be painted. These things contain some bushings, which are over there. There, these two bushings. Which will obviously be pushed back into this, and then it's going to be oily and we don't have to worry about it. I did really try to limit the sandblasting and the sort of precision surfaces to a minimum, but they were pretty rusty, so I was like, screw it, just blasted them for a very short time. I think it's going to be fine. These things aren't like bearings or anything, it's just sort of slightly precision. And you can also see that even just a little bit of ding immediately removes that. So this isn't going to be deep surface modification. Yeah, so these things are all completely cover free, which is why they started rusting immediately. So we'll have to hurry up painting them. And to add a little bit of contrast, I think I'm going to be painting these things in this sort of gray, textured gray. I'm not sure how you call this texture in English. In German we call it Hammerschlag look, so sort of hammer strike look. Not sure. Probably not that. But yeah, so this is just to keep these things from rusting. They don't technically need to be painted. And with all the oil that's going to be running out there, they likely don't even need any paint at all. Alright, so this thing here will have to mask, because only the front side needs to be green. And yeah, gonna start painting these things, and when I'm done, I will be back. Alright, with the things painted, it is time to move on to the next problem. I also actually coated this little ring here, which won't get painted because it's on the inside of the oily part of the headstock. I just coated that in a bit of whey oil because it's the nearest oil can I had around, just to make sure that it doesn't rust. You should never leave any sort of steel parts out in the open unprotected. They're gonna rust very quickly, especially if you've sandblasted them and there's like no oil or anything on them. But anyway, moving on to the next problem, and that is the feed clutch. The feed clutch, at least what I call the feed clutch, is the part that connects the spindle with the feed gearbox. And that was comprised of these parts here. Ignore the mess on this side. That's just me not being too lazy to clean up. So we're looking at these things here. This thing had not only the ability to actually connect the spindle to the feed box, but also to reverse the feed direction. So this is a clutch that could not only disengage, but also change directions. To achieve this, they had on this spline shaft first this gear, without it actually being connected to anything. This is free running. It doesn't have a bushing in it, but so far it seems fine, except for a couple of burrs here and there that make it run a bit roughly, but that should be not a problem. And then the second gear on here, which was sitting on this part of the shaft, also free running. And I'm forgetful. The little traveler thing in the middle that was actually riding on the spline shaft. This has splines cut into it. This thing was moving back and forth on here, with this gear on here, and this little bevel gear on the side like this. This here was actually what was being fed by the spindle. There was a second gear connecting it to it, riding on this part. And then you had this bevel gear arrangement here. So that means this gear, if this was turning that direction, that bevel gear was turning like this. And it's hard to do because obviously I'm not a gearbox to hold them in place. But you can see that this thing here is turning the other way around than this thing. And this little traveler was moved either between this side, where it engaged that, or the other side where it engaged this gear here. And depending on which gear was selected, either this one for forward or this one for reverse, well, the direction was changed. But the one problem that you can probably see, you can see that these flanks aren't really rectangular. Neither are these here. These are actually really bad. See how this is not at a right angle to the surface like this, but more angled that way, same as this. This thing is angled this way, and that results in the clutch effectively wanting to push itself apart. So you can see as I turn it, it's trying to move past it, because we're not on a shaft. We can fix that. But in addition to it trying to turn the entire shaft, it is trying to push the little traveler, whatever, out of the way. That, I believe, is what is causing the issue with the gearing. How do we fix this? Well, quite simple. We just file these corners back into square again. In fact, if we just look at the surface, you can see that somebody has already done that in the past. On these two edges, which are exactly the ones that are engaging with this thing here as it's feeding forward. So we're going to just do the same thing that this person here did, and hopefully that will fix the issue of that pushing itself apart. But first, we would want to look at the actual bearings. These fit into either this side here. Sorry, wrong one. One of these things is smaller than the other. Fit into here or into the other side. They are conical, so tapered to this side here, which allows you to correct for wear in them by tightening the screw on this side more. However, in order to prevent these things from putting excessive force, clamping force onto the shaft, there are two little shims in these cutouts here. You have to figure out which one is which. But once you screw these things in, pulling them into the taper, closing them up, these are no longer loose. Now, as I said, this allows you to correct for wear, however, only to the point where this thing here is completely crushed. This thing isn't really going to deform, at least as long as you tighten it with a reasonable amount of force. So this more or less limits the amount of wear that you can correct for. This means that if the wear is too much, you will need to replace this shim here. And if we look at the other bearing, you can see that it is actually really not in a great shape. It does still fit the shaft, and there is almost zero play if it's installed, but it is scratched on the bottom, and there is a... I'm not sure if there's a seizure marks. Yeah, it doesn't look great. So this thing is definitely more worn than the other, and this is the one that leaks oil. So if you have the little ring running over the top here, this just hangs in there on the shaft, runs through a little oil vat down here, picks up the oil and deposits it onto the shaft, and that oil, instead of running out through the bearing into the collection thing and back into the oil reservoir, just runs at the front of the shaft and onto my wall. Or into the foot of the lathe. There's about 5 millimeters of oil down there. Seriously, it's that much. So this definitely needs to be fixed. This one here is fine. That doesn't really have any wear in it, but this one does. Now, how do we figure out if it is actually worn or if it's some other problem, like, for example, the little felt wipers on the end of it? Well, the idea that I came up with is that we somehow need to put it over the shaft and compress it together to the point where it actually makes perfect contact with it. And instead of using some sort of clamping thing, I thought that maybe we should use cable ties. Really, because the only clamps I have are C-clamps, and they wouldn't put like uniform pressure onto this. So we're going to be trying to use cable ties, and then using the calipers to measure the width of this gap and see if this thing is actually too thick or not. So let me put that on and we'll be back then. Alright, the bearing is clamped on, and unfortunately it doesn't look good. You might be able to see that the slit where the shim used to sit is a bit narrower on the bottom than it is on the top. Just have a look at this. Right at the one side of the taper, it is 0.88 millimeters, while at the other side of the taper, it's more like 1.13, and that's about a difference of 10 to 20 thou, probably. I'm bad at converting, so sorry. I'll put the conversion here. definitely not an insignificant amount of diameter difference from here to here. Now, what does this actually mean? Well, if we think about it, if the diameter down here, which is basically what we're measuring, is smaller, because this little slit is narrower, it means that the bearing has worn more here than it has here, which makes sense. This is the loaded end towards the chuck. It actually does sit on the shaft like this. And this is the one that is towards the back of the headstock. So this side should be experiencing the most load. What else does this mean? Well, it unfortunately means that this thing, at least in my opinion, is short. Because if we were to say, oh, just sand the shim down on one side so that you can clamp down properly again, so make it thinner here than it is here, we do run into the problem that, of course, it's not just the slot width that changes, but also the diameter of the taper on the outside, and thus the taper angle. So if we try to clamp it down in a way that makes this thing here be narrower than that, we would effectively be crushing the taper here. Now, I must say that it is not as bad as you might think, because the lathe still works and it has very little play in the spindle. I've tested it with an indicator and been using it for a few months, with the only real problem being the oil leak. But in order to fully restore it, I would have to either turn out the inside of this thing here to make it well, what's the geometric equivalent of parallel to a tapered surface? It shouldn't be parallel, but it should be rectangular to the taper angle, maybe? Just turn it so that the slot width and the taper on the outside is proper again. That would be one option. We wouldn't be able to take a lot off. Or the option 2 would be to just turn a new one. I've checked, the raw stock costs about 70 to 80 quid, depending on where you buy it, for, well, enough to make one. But then the issue is, can I actually manage to do this properly? I don't know. I mean, I'm not a real machinist. I've been having a bit of fun turning some aluminium and some steel, but trying to make a bearing, I don't know how hard that is. So I will go talk to some of my colleagues and friends that actually know what they're talking about. And then I will make a decision and be back. And there we go. There's the money shot. That's the headstock assembly finished. With the one exception that the front bearing still needs some work. I will come to that later. First, let's just have a quick look at how everything fit together. Just do another money shot. Ta-da! I really love the red color. Just looks so great. Okay, so taking this top cover aside, we can have a brief look at the gears. So this here is the belt pulley, where you have two belts running off to the gearbox down here. That, however, doesn't directly drive the spindle. Instead, the spindle is only coupled to these gears through some keys and this front gear here. So if we move to low gear and turn this, you can see that it is free spinning on the actual spindle and driven through the large gear down here and another small gear in this little liftable thing, not sure, you saw that earlier, that is connected to the high-low selector. And when you're in high speed, then this is coupled to that spline. There's a little spline cut into the face of this gear, and that directly couples the pulleys to the spindle. And if you go to low gear, you have the second gear reduction through the gear on the bottom there. That is working well. It's a little bit, I don't know, it doesn't feel quite as nice as it used to, but that is probably just because I turn things around and maybe have them in a different orientation relative to each other. So I'm sure that's going to be getting better as I use it. In fact, it already is. Then we have on the other side the second important part of the headstock, and that is the feed clutch. Well, not necessarily the feed clutch directly, but the feet disconnect. So if we just spin the spindle a bit, you can see that this gear here rotates with it. We can, however, also push it aside, not quite that far, and that disconnects it. This is what actually powers the output to the feed box down here. So if we spin this the other way around, obviously that's going to be able to turn as well. And in between this thing here and these gears sits the feed clutch that was broken where we filed the teeth rectangular again. And if we just move over the direction, you can see that this thing now turns the other way around. I haven't actually oiled any of these things yet, but that is because we actually have to take this thing apart again. In order to install the belts, once the machine is back together, we will obviously need to take this thing out, and we can only do that if we remove the spindle. So this is only installed for your viewing pleasure here. Also, another thing I forgot is the little lubrication ring. There's a little ring that runs on the actual spindle through a vat of oil in the bottom, which you fill with oil through these little ports. And that runs through that little puddle of oil, picking some up and depositing it onto the top of the shaft. I forgot to put that onto the front here. It's this thing. That is actually supposed to be in there. So I'll have to remember to put this into there before I actually put in the spindle. But otherwise everything is together as it should be and turns nice and easily. As you can see, I didn't tighten this up quite as much as I should, but still, I would say this is fine. I have also replaced all of the oilers with some new brass ones. I actually spent a little more money to not get the galvanized ones, just because these things I thought would look nicer. And there's actually one extra oiler when compared to the machine before, and that is this one here. This had a hole for it, but no oiler in it. So I almost suspect that whoever installed the thing, or put the thing together again the last time, forgot about this. And this oiler is what actually provides the feed clutch with oil. So that thing not having any oil in it definitely wasn't good for it, and you might have seen a bit of discoloration and heat damage that has been done to it, probably because of this very fact. So this just had a new hole drilled. Fortunately, the hole is at an angle downwards, and I couldn't really install the oiler at that angle due to the little ridge here. So I had to drill an oversized hole and punch it in sideways. I think it's still going to work. It's just not that easy to get to. If it was facing down, of course, it would be much easier to get the oiler, to get to the oiler. And finally, back to the biggest problem at hand, the front bearing. As I showed you in an earlier part of this video, it is worn conical on the inside, meaning that no matter what I do to it, unless I put it in another lathe and actually surface the inside again, I wouldn't be able to reinstall it properly, at least not while properly contacting the entire shaft. And I have decided that I am going to make a new bearing for it. I've made a drawing, which you can see here, very simple, because the geometry itself isn't actually that hard. The issue is just that, well, I don't have a lathe that works right now, so I will have to reassemble the lathe like this, then get the new raw material in, machine that, and actually manufacture a new front bearing, and then take the entire lathe out apart again and fit it. But I think because this still works, there is no play in the spindle itself. I've checked it with an indicator when I got the new chuck, and it's like maybe 1/100th of a millimeter less than the resolution of my indicator anyway, so that I think should be okay. And because of that, I will have to accept the massive oil leak for a little longer until I actually manage to make a new bearing. But again, that should be the next project once the lathe is back together. Alright, thanks for watching. I hope you enjoyed the rebuild of the headstock as much as I did, even though we didn't quite finish it. The front bearing here, we are going to get to later once the machine is reassembled. And I hope to see you again in part 3 of the rebuild where we will be looking at the feed gearbox and repairing that, figuring out what that front lever does, if it's actually designed as another gear or if it just disengages the lead screw. That is also possible. Yeah, so see you then. Make sure to subscribe if you don't want to miss it.